So let us do example 8.2 from the NCERT. So we have three masses which are equal and which are fixed at the vertices of equilateral triangle. So we have equilateral triangle and three masses are fixed at the three vertices. Okay. Now, what is the force acting on the mass 2m placed at the centroid of the triangle? So this is the centroid where the three medians meet. So in equilateral triangle, perpendicular bisector, median, bisector angle, all three are same. So this is 2m. 2m is placed over here at the centroid. Okay. What is the force acting on the mass 2m? So force acting on mass 2m. So take one by one. You have mass m and this is your mass 2m, right? So let us take it A, this vertex, and this is B vertex, and this is C. So this is your vertex B and 2m. Okay. Now you have vertex A where mass m is placed, and you have this G which is your centroid. Okay. And so I'm drawing three separate figures. Okay. So this is your G where you have placed 2m mass. Now you have this point as C where mass m is placed, and this is the point G centroid where 2m mass is placed. So students, so here the force on 2m. So 2m will be attracted towards this mass. Here 2m will be attracted towards this mass. Here 2m will be attracted towards this mass. Is it okay? So what is the force on 2m? Okay. So let us calculate one by one. So let us start with this. So force on mass 2m, I'm going to add all these three forces. Okay. That is so Fr is equals to resultant force. I call it resultant force equals to force on force at centroid due to A, force at centroid due to B, and force at centroid due to C. So force at centroid, force at on 2m due to 2m placed on centroid G. So force at G due to the mass at A, and force at G due to the mass at B, and force at G due to the mass at C. See the important, we call this principle of superposition. So I'm adding it, principle of superposition. So what is this principle of superposition? See, there are forces between A and B also. Like A and B are also attracted towards each other. So but when I'm talking about force on R, so when the force acting between two particles, it is not affected by the presence of third particle. So if there is force acting between G and A, it is unaffected by any other particle. Okay. So there's no impact of any other particle present over there. So that is the principle of superposition. So we can add these individual forces, like, so this GA, this GB, they are not impacted by any other forces. Even GB is not impacting GA or GC. Okay. So they are not impacted by the presence of other forces or by the presence of other masses, whatever. So always take in this case, like we have this force, so gravitational force, so these field forces, so gravitational force, then we will study electrostatic force in 12th class. So same superposition will use over there. Instead of masses, there will be charges. Okay. So that's the principle of superposition, that when we are finding the force on one mass, So we simply added one by one so I am studying force on mass 2m. So I will be individually adding the forces, like force on 2m due to m at A, due to m at B, and due to m at C. Okay, so individually we are adding. So that's the principle of superposition. So we will use it in the physics at many places. This is the beginning. Okay, now what is this? Let us calculate this GA, GB and GC. So this is your GA and this is your FGB and this is your FGC. Simple, you know the formula. So what is FGA? FGA is equals to G into M1 into M2. So write the formula here, G M1 M2 by R square, and then the position vector, that is minus R cap, was there in that figure. So here what is it? What is M1? So this I am talking about. So M1 is your M, M2 is your 2M, divided by how much is the distance between them? So the distance between them is so all these distances are same. So how much is the angle over here? So this angle is look at this figure. This is 360. So 360 is divided in 3 equal parts. So one angle is 120. So 120. This is 90. So this angle is 30. So this is our positive axis. This is angle 30 degree. Now it is further given that AG, BG and CG, so these all are 1. So this length is equals to 1. This length is also equals to 1. So of course they are all same. This length is also 1. So that is given to us. Okay. Now, so what is the distance? Distance, it is given to us that this is also 1, this distance also 1, and this distance also 1. So very simple. So distance is 1 square. Now what about the direction? What's this direction of GA? So you can clearly see that this is along the y-axis. So this unit direction of the y-axis is j cap. So that is why I multiplied with j cap. Now what about the G means on force on 2m due to m placed at B. So obviously 2m will be pulled by this. It was pulled by the mass at A, and it will further be pulled by the mass at C. So this direction is clearly j cap. What about this direction? So this direction, now that's important. So how do we write this direction and how do we write this direction? This we need to study. Otherwise the magnitude is the same, GM. So because this is M, this is 2M divided by 1 square. Yes
सर,
yes
माइनस जे कैप होना चाहिए था इसमें.
ये या minus j cap. Yes,
यस सर.
okay, that's a good question. See, try to understand what is the direction of force over here. Let us find out. That's a good question. See, force acting on 2m. So 2m will be pulled towards m. Okay, so that's the direction of actually in last question we took this direction as vector r, the formula that we derived. This is vector r. So vector r and this force, they were in opposite direction. So that is why there was in the formula there was minus r cap. Okay, but here in this figure you can see this is the direction of your force and this is your y-axis. So this is the unit vector j cap in the direction of the force. Okay, this direction is minus j cap. So force, if the force were in this direction, but the force you can see that this 2m is pulled by this mass m. So that's the direction of force, that is along the y-axis. So that is why here I have j cap. Understood it?
Yes.
Okay. Now students, the important thing is the directions. How do we find this direction, this direction? So this direction, you can see that this is your I cap, if and this is your minus j cap, right? And this is your minus I cap, this direction. So minus I cap minus j cap. This is the now you will be moving this and this direction, and this angle is 30 degree. Okay, you know this is 90, this is 120, so this angle is 30 degree. So if you have this angle as let us draw this figure separately. So that's your direction, and I'm resolving this direction. This is I cap minus I cap, and this direction is minus j cap, right? And what will be this direction? So what is the magnitude of this? So this you know that this is 1, right? This 1, and this angle is 30 degree. Okay, so this is so you can write this is the hypotenuse. So hypotenuse 1, so this is opposite side, and this is adjacent side. So what's opposite side? Opposite side is equals to hypotenuse sine theta, and adjacent side is hypotenuse cos theta, right? So this side will become hypotenuse sine theta. So hypotenuse 1, so 1 sine 30 degree. So this sine 30 degree. So this is so this vector, the magnitude is sine 30, and this vector is minus j cap. So the magnitude will be j cap sine 30 degree. And what will be the magnitude here of this vector? That is minus I cap, hypotenuse 1, so cos 30 degree. So minus I cap cos 30 and minus j cap 30 degree. So this vector is resolved in two components. So this vector is equal to minus I cap cos 30 minus j cap sine 30. So this vector is resolved in these two components. Okay, so that's how we write this direction. And similarly for this, means for this, for GC, we can similarly write. So the difference here is, here it is plus I cap. So that's the only difference. Instead of minus I cap, it is on this side. So this direction is given by this. Okay, so simply we will add these three. So when we will add these three, so this whole will become 0. How is it become 0? See, this is minus I cap sine cos 30, so this minus will come here, so minus and plus this will be cancelled out, and what you are left with here, you are left with, so these two are same. So here you get, what is the value of sine 30? Sine 30 is 1 by 2. So so what do you get here? You will get 2, let us calculate this part. What will be this part? So here it is 2gm square j cap plus, in the brackets, this is your plus, so 2gm square into, so I told you that this will be multiplied with minus, and this will multiply with plus, so they will cancel out. So we are left with minus j, and this 1 by 2, so minus j by 2. And here also it is so this is the same, 2gm square, and here minus j by 2. Okay, and again So whether you add this bracket or not doesn't matter. So this is what do you get here? So this equals to 2gm square j cap, and what do you get here? Minus j cap by 2. So this will become j cap minus j cap, and minus will come here, so minus 2gm j cap. So that will be 0. So that's the net is 0. Okay. So even on the basis of symmetry, by common sense you can see that this 2m is pulled by these three forces. So it's the symmetric case. So in the symmetric case, the net force acting on 2m is 0. Okay, because the magnitude of these three forces are same. Magnitude is same. You can see that this is the magnitude of the forces. That's same. Why the magnitude is same? Because magnitude is equals to gravitational constant into m1 into m2 divided by the distance. So this is 1 square for in all the cases, and here the m1 is suppose m in all the cases, and m2 is 2m in all the cases. So the magnitude is same of the forces. So so 2m is pulled in these three directions with equal force. So that is why the so one expect on the basis of symmetry that the resultant force ought to be 0. Now what happens if the this is doubled, the mass at the vertex? So instead of 2m, write 4m. So that's the only difference. So write 4m, 4m, 4m. So the forces will be changed. Okay. So here this FGA, this force, this FGA will be G into, so replacing this m with this 2m. Okay, and this these forces F dash GB will be, so only this mass is doubled. So mass at A, instead of m I have changed it, this instead of m I have changed it with, so that's my B part. What if the force of the mass at vertex is, so I have changed from m to 2m. So the forces between here and here, they will remain the same as earlier. So if these forces are same, so this will remain the same, only this thing will change. So the resultant will be 4gm square minus j minus 2. So here also it is square gm square. So gm square j cap. So the resultant will be 2gm square j cap. So this is the magnitude of the force. So now the net force, now the net force on 2m is 2gm square in y direction. Okay, now it has net force. I hope you have understood this question. Now if we have till now we were studying that we have point masses, right? Now instead of point masses, we have an extended object, rigid body like Earth, and another is the point mass. So if we have this point mass and another we have a body over here, so suppose the force, so for that we need to note these two conclusions. The force of attraction between hollow spherical shell of uniform density, so this is hollow, okay, and this is shell, and a point mass m situated outside is just as if, so suppose its mass is m, so this will behave like the whole mass is concentrated at the center of the shell, because this is the center of the mass. So of course this is when any force is applied on it, so it will be pulled by this mass, and this mass will definitely pulled by this. So both are pulling each other with equal and opposite forces. So when this mass is pulled, we have studied that the force applied on the center of the mass, and we assume that the whole mass of this body is concentrated at the center of the mass. So by symmetry, the center is the center of mass, so whole mass we assume that it is at this point. So it will behave as a point mass with mass capital M at the center, and this is your mass M. And now you can calculate the force between them. And even if students you have two spheres, so then you have to take the distances from their centers. Okay, and here in this case you have understood this. We know earlier also that by the definition of center of mass, we know this concept earlier also, right? Now the second point, the force of attraction due to hollow spherical shell of uniform density on a point mass situated inside it. So how much that, so this is the your hollow spherical shell, and you have a point mass over here. So this is mass now. Instead of outside, this mass is inside. So what will be the force of attraction due to this? So force of attraction here is 0. So if there is mass inside, so there is no force acting on this mass, because see it has a lot of particles on the mass, and all the particles are actually pulling this mass. So these forces are actually they will cancel out each other. So we will resolve their components along x-axis and y-axis, and adding all the forces, we find that the net force on this particle is 0, so which is inside the hollow spherical shell. So net force of attraction is 0. Okay, so students, these are the two important conclusions. Now this is very important concept that we are going to do. We are going to find the value of gravitational constants. Very easy. Okay, very important, but it is very easy to find. So because we know this formula, we know m1, we know m2, we know the distance between them, but what is the value of this g? So this value of g was experimentally determined by English scientist Henry Cavendish in the year 1798. So when the Newton gave the law of gravitation, around 100 years after that, the value of g was established, was found, determined. So you can see this experiment. Students, do you remember that the position of the sun when it was ellipse? So it was also given s and s dash here. So I told you that you need to ignore one of the values, so don't consider this value. So in this diagram also, so he has given you that two scenarios are possible. See this, so first of all let us see this what this diagram is. This is a rod, and this rod has length capital L. Okay, so this is your rod here, this is your rod, and the length of this rod is capital L. Next point, this is your wire. Okay, this is your wire, this is your rod. Now at A and B we have small spheres. Okay, small spheres are attached over here at A and B, and we have big spheres over here at S1 and S2 position. So if S1 is on this side, then it is on the other side. So it is on the right side of B, this on the left side of A. So on the opposite side we are placing. So, and this position can also be possible. So either take this position or take this position. So don't draw these both the figures in your when this question will come in your exam. Okay, so you need not to draw this. So either draw the spheres over here or over here. So both the scenarios are given, students. So you need not to draw this. Okay, so this is the language of the figures, language of physics that you need to understand. Now what happens is that you have these very large spheres. So obviously due to gravitational force, these small lead spheres, they will be attracted towards this, and here also it will be attracted towards this. So this rod will move, will twist little bit, not more, but it will be twisted. So this rod, its position will be twisted little bit, and this angle theta. So it is twisted by angle theta, okay, by some force. So students, we have read this case that we have a spring over here, and this spring was pulled, okay. So when it was pulled by some mass over here, so here also this block, so I pulled this block. So you know that this is the displacement x, and there is a spring force acting in this direction, and that spring force, the magnitude of that spring force was directly proportional to x displacement, and this is the spring constant k, and that's kx. So spring force was equal to kx, so that is restoring force. So that was the restoring force here, Fs. So here also, when this rod will be rotated, this wire will be twisted, and this wire will be twisted, it will try to regain its shape. So when this wire will be twisted, it will try to regain its shape back, right? So there will be restoring force, okay. So here this restoring force is definitely means if theta is the angle of twist of the suspended wire, then the restoring torque is proportional to theta, and that is equals to if theta is the restoring couple, so here instead of force, so we have restoring torque, right, because it is here it is rotation, so restoring torque, okay, in the wire. So if theta is the angle of twist, then the restoring torque is proportional to theta, and restoring torque is given by tau into theta. And what is this tau? This tau is restoring couple per unit angle of twist. So that is why it is multiplied with theta, okay, so that you get the total restoring torque. So this is where do you use these kind of things, that this is this restoring torque, like, okay, this something like this torque here is something like density, right, or it is something like mass per unit length, small l, that if this is the length, then if the length is x, so that is x, what will be its mass, so multiplied with this ml, so you get the total mass, right, total mass in this length x. So what is the total mass in this length x? So that is length into its mass per unit length, right. So this length will, so the unit, you will get the units of gram here, total mass. So similarly here, students, will deal with this more and more in physics, like here writing it in this way. So density is writing over here, so like density is equals to mass upon volume. So what will be the mass of 2 centimeter cube? So this is, suppose mass is 100 grams per centimeter cube, so that's means, or 1 gram per centimeter cube is the volume over here. So how will you write this mass is, suppose 1 gram per centimeter cube, so that's the density, right. So multiply the volume with density, you get the mass. So this is what we do in physics. So now this so it will start rotating, okay. So gravitational force want it to rotate, but restoring force doesn't want it to rotate. So they are means just like in equilibrium, isn't it? You have reactants and you have products. So what happened? Concentration of reactant is decreasing, so its concentration is decreasing, and reaction of of the product is increasing. But you reach a certain stage where the same number of reactants are converting into product and same product are back to reactant. So you got an equilibrium, right? Chemical equilibrium. So same here the two forces are acting. So as your theta is increasing, due to the gravitational torque, right? But simultaneously there was this restoring torque which wants it to go back. Similarly, like here you are stretching the spring, so more you stretch the spring, more will be the spring force. So spring force is increasing. So here also restoring torque is proportional to theta. So more is the theta, so restoring torque is increasing. Okay. Now there comes a point that when equilibrium will reached, and at equilibrium this gravitational force, that is your g m1 m2 by r square. So r is d is the distance between, so this distance is d, so that's your d, distance between this small sphere and capital. So this distance is d, and this L is the length. So length of the rod. Now how have we written this? So this we can write it as AB cross F. So when we have two forces like in equal and opposite direction, like in this case, so what is the net torque acting on it? Net torque is AB cross F. What is the magnitude? Magnitude is simply the length. So here this is the same case. So here the difference is, here you have two forces in this direction. Instead of this, here this is a larger sphere, this is a small sphere. Here you have larger sphere, here you have small sphere. So what is the net torque acting on it? That is your gravitational torque. So this length, that is your L, and of course the cross product. So you are taking the magnitude. So the angle between them is, so theta is equals to 90 here. So sine 90 is 1. Okay. Yes. So, and what's the force here? Force, the gravitational force, that is this g m1. G capital M is the mass of the larger sphere, and this small m is the mass of the smaller sphere, divided by d square. So this is the force. This is your F, this one. So this is the force F, same force acting in equal and opposite direction. So this force, what is this force? This force is definitely g m1 m2 upon r square. So g, mass of S2, into this mass, and mass of larger sphere into the mass of smaller sphere, and the distance, and I'm telling you the distance between their center is d. So g m1 m2 by r square. So this is the force, this force which is acting in this, and of course it is rotating like this, so that they will be adding up and multiplied with L. So AB into F. So that's the formula, AB into F. So this is your F g m1 m2 by d square. This is the rotational, this is the gravitational force, this one and this one, and this L is the length, this L is the length. So simply AB cross F. So this is the gravitational torque due to this couple. So couple is formed, and this is the restoring torque. So due to the torque, the suspended wire get twisted, so it keep on twisting such time when a time will come when both the forces will be equal, because greater as the theta is increasing, this force is increasing. It depends on theta, and definitely as the L is decreasing, this force is decreasing. So actually the gravitational force is this L is same, but this distance is decreasing, so this force is increasing. Sorry students, just understand this point here. So what we have done written here is restoring this gravitational torque. Gravitational torque is force this AB into F. So AB is L into F. F is your this force. So one of the forces you can take. So G, mass of bigger sphere, mass of smaller sphere, upon distance between the spheres. Distance between these two masses is d square. So this is your gravitational torque, and that is equals to restoring torque. This is your restoring torque. So as this rod started twisting in this direction, so due to the gravitational force, so there will be restoring force. See, this is torque, don't call it force. By mistake I'm calling it force. This torque, rotational motion is here. So this is your restoring torque in this direction, opposite direction. So they are acting in opposite direction. So equilibrium will reach when both of them will be equal. So this wire will stop at that point. Its rotation will stop when there will be equilibrium, because so these are the two torques, but initially gravitational torque is greater and restoring torque is lesser, but as more twisting is there, just like spring force increases, that means as the displacement is more, so restoring torque will increase. And see this, what is this d? D is the I told you that d is the distance between this larger sphere and this smaller sphere. So as due to gravitation it will twist, so this distance d is actually it is decreasing. So as this d is decreasing, gravitational force will increase. Okay, these four things are constant, but as this theta is increasing, restoring torque is increasing, but this is increasing at much faster pace as compared to this d. Okay, so means as compared to this gravitational torque. So gravitational torque is also increasing, but restoring torque is increasing at much faster pace. Okay, and then comes a point when these forces are equal and opposite, and at that point the wire will it will keep on twisting, but the suspended wire gets twisted till it will keep twisted till the time comes when the both the forces are equal. And now you know the value of L, you know the value of this M, you know the value of this M, you know the D, you know you can calculate torque and theta. So and then you can calculate G from here. So G is equals to tau theta into D square divided by M and L. So and this is the value that you get from this 6.67 to 10⁻⁻11 Newton meter square per kilogram square. So that's how value of G was found. So students, just you need not to write all this explanation. I will send you the notes in PDF form of this chapter, like this the whatever I have taught. So you have to just write these notes in the exam. You need not to write. So rest of the explanation is just to get the concepts clear. So only even if you watch the video in the beginning, this page will be there will be nothing, there's nothing written on the page. So just note it down. So rest of the things are explanation to get the concept clear. Okay, is there any question anybody would like to ask? Okay students.